In this session, we will continue to uncover object-oriented programming concepts. And in the last session, we have uncovered inheritance and also method overloading. In this session, we will try to uncover method overriding and a few keywords like super and final, and also we will try to uncover abstraction. So what is method overloading, which we have discussed earlier? Method overloading, we will have same method name with different parameters. So what is method overriding? Method overriding, same method name with same parameters. And how is it possible? For method overriding, we need a parent class and a child class. Let's see some examples for method overriding. So I have a class P, which is parent class, and I'll define a method M and say this is a parent method. And I'll get rid of this second child class from the previous example. I'll define a child class and it extends the parent class. And for now, I'll just get rid of any method in the child class and try to compile and see. I need to get rid of this whole program's object. So I'll create an object for child class and define it as, and also call the object method M. Let's try to compile this and execute. So I do not have any methods defined in the class, so it called the parent class method. I have not implemented the method overriding as of yet. I'll just take the example here first and put the results there. So say, for example, I'll define the same method. That's a requirement for method overriding. The method name should match the parent class method and say child class. Now, the child class is having the method implemented. This time, we are just gonna get the child method execution, not the parent, because this is method overriding and we already have a method the same name as parent. So let's execute. This time the child got executed. And that's method overriding. So what did we learn? For example, if the child is not satisfied with the parent class implementation, then obviously child can define its own implementation for the parent class method. This concept is called as method overriding. So let's summarize what is the difference between method overloading and method overriding. So overloading, method name must be same with different parameters. Whereas overriding, method name must be same with same parameters. That's the key difference between method overloading and method overriding. So now let's move on to uncover the super and final keywords. Let's begin with super. So if you remember in the earlier sessions, we have covered that parent class is also called as superclass, and child class is also called as subclass. So we can use super keyword to interact with parent class. So how do we do? We can use super with variables, and then we can use super with methods. We can use super with structures. Let's uncover each of these with examples. So for super with variables, what I'll do in the parent class, I'll define an integer a is equal to say 10, and I'll not implement any SOP statements in parent class. And in the child class, we'll define integer a again and assign 20. And say, for example, I'm just summing the numbers a plus a. And if I try to execute, what I'll get, obviously, when we use a, it currently points to the local variable. So it's going to be 20 plus 20, which is 40. I have not used super as of yet. Let me compile and execute, and I got sum 40. I'll just take this program, put it out here for the notes, and also copy the result. Now I have a requirement that I do not want to add 20 two times, but I want to add 20 with the parent class 10. So what I'll do, we have uncovered this keyword in last sessions. So I'll use this dot a and it will point to 20, and I'll use super dot a, which will point to 10 in the parent class. So this time it's gonna be 20 plus 10, which is 30. Let me compile and execute. So this time I got 30. That's how we use super with variables. Now let's move on and uncover super with methods. So for example, let me implement a method inside the parent, and I'll just make it as parent and then get rid of this. And I'll get rid of the integer here. And in the child, I'll implement another method. And try to run this now. I'll get the child class output. That's the expectation. I didn't use super as of yet. I'll just retain the program and the results here. Save it. So I have a requirement that I need to implement the method which is inside the parent class, even if I define the same method inside the child class. For that, I'll just do super and m method. And now let's see how this works out. Execute. Now it worked out well. I have executed the method inside the parent class as well as child class. That's how we can use super with methods. I'll get the result and put in the notes. Now let's move on and uncover super with constructors. Constructors we have covered in the previous sessions. What are the requirements for constructors? The constructor name should match the class name, and you do not need to explicitly call constructors because constructors are used for initialization purposes, so they will be executed automatically when the program starts execution. So now let's see an example. Like I said, the name should match. The constructor P should match the class name P, which got matched, and I need to make this as constructor C, which will match the child class C. And I do not need a method dot method here. I'll just use super, and I do not need to explicitly call constructors. It will be executed automatically. And let me compile this and execute. So this is how super can be used using constructors. Now let's move on to the next keyword, which is final keyword. So if we want to provide some security restrictions, then we can use final keyword. Let's try to uncover final with methods, final with classes, and finally final with variables. We'll see each of these with some examples. Let's uncover final with methods first. So for example, I have a void method m in parent class, and I have void m in my child class. I'll get rid of the super here. And if I want to call the method, I'll call object.m. So this will execute and it has no issues. But for example, if I want some restrictions in my parent class that I don't want anybody to call or override this method, I'll declare this as a final method. Now, when I try to extend this to child class, it should not allow, it should throw an error. It says you cannot override a final method. So if you want to provide any security to your parent class method, then you can use final. Now let's look at final with classes. It is same like method. So here, let's say class doesn't have any implementation. It does want to extend parent class. If I do not want anybody to extend my parent class, then I'll define the final class as final. Then I'll try to compile. I should get an error. So it says cannot inherit from a final class. So that's how you can secure your classes with final keyword. So what is the need for a final to declare in front of a class? For example, you have, say, implemented some 1K plus lines of code, which you do not want other classes to extend. In that case, you can define it as a final class. Let's move on to the final variables. It's again the same thing. I'll just get rid of all of this. Say, for example, I have an integer x is equal to 10. And if I try to increment let me print the initial value. And if I try to increment and print it again, it's going to print 10 and 11. But for example, in my program, see this x is constant and I do not want anybody to increment it. So then I'll define it as final. And if I define it as final and anybody is trying to increment or change it, what we get an error saying cannot assign a value for a final variable. So what is the use case? For example, in math, you have pi value, which is constant, and you cannot change the value of a pi, right? So let me show you the profile of this java.lang.math. And if you see here, it is it has the pi value and it is declared as final, which means that it's a constant and you should not change it. So that's the use case of final in variables. Now let's move on to the next concept or keyword, abstract keyword. If we don't want to provide implementation for any method, we can declare that method as abstract method. That is without any implementation. For example, I'm implementing a project for a company called Toyota, which is a car company. So what I'll do, I'll create a Toyota class, and inside that, I will create an abstract method and say the method name is start engine. So this is the parent class for the Toyota project. And I have one method, which is start engine. And I do not want to give any implementation for this method. And that's the reason I set it to abstract. As soon as I have at least one method in a class, which is abstract, then you have to set the class abstract class. Let me jot it down. If class has at least one abstract method, you need to define that class also as abstract class. So if we do not want to put any implementation inside an abstract method, then why do we need it? I'll explain here with this simple example. I have a car company called Toyota, and it has so many cars, and each car has this method called start engine. But there are different models in this Toyota company, like RAV4, Sienna. So each car should start, but the way it starts differs. For example, for some cars, you need to put the physical key inside to start the car or start the engine. And for some cars, which are keyless, you just have a button and then just press the button, the car gets started. Regardless of what car you have, you will have this start engine method, and you will not give any implementation, and you will define it as an abstract method. Then after that, for each class, for each car, you will define another child class, and then you will set the implementation for the start engine. So let's see how we can achieve this with an example. So for example, I have the parent class, which is an abstract class because I have one abstract method inside it, which is start engine. Now I have a child class, and say it is RAV4, and then it extends the parent class Toyota. So here I'll implement the start engine method. And how do the RAV4 starts? That's what is implemented here. Let's say, for example, I'll just mimic a SOP statement. And here, what I'll give, RAV4 use physical key to start the engine. Okay, I have extended the child class RAV4 and implemented the logic for the start engine. And in my main method, what I'll do, I'll just create a RAV4 object and say RAV4 new RAV4. Now, how do I start the engine? I'll just RAV4 dot start engine. And let's see if my RAV4 starts. Compile. And start the RAV4. RAV4, you use physical key and RAV4 start. Now, let's see another child class. Say, for example, I have a Sienna. And it again is from the Toyota company. But for Sienna start engine method, use button keyless entry to start the engine. For Sienna, you don't need a physical key. So I'll just create an object for Sienna and start the Sienna. But for Sienna, it's gonna have keyless entry and button to start. Let me compile and start both cars. So RAV4 use physical key to start the engine. Sienna use the button or keyless to start the engine. So now you know what's the use of abstraction. So you will just set a method in the parent class, which is absolutely necessary for your child classes, but the child class will decide how to implement that method. That's the abstraction concept. I'll put the result here. I'll summarize. So, what is a concrete class? Concrete class, it's a normal class where all implemented methods which are fully defined. These are normal classes. And what is an abstract class? It will have partially implemented methods. You might have implemented methods plus non-implemented methods, which are abstract methods. I will stop here, and the next sessions we will uncover interfaces in Java.